Voyager 2 has been around for more than 40 years, slowly falling into the void far beyond the planet's reach. In the past, at the cold edge of the solar system, it ventured into the great undiscovered. A ghost ship, guided in the 1970s by Earth's last whisper, we imagined it would vanish slowly, fading into cosmic background noise. But it didn't. It recently delivered something back, not just a routine data transmission, but a message that made NASA scientists pause. A sudden increase, an unforeseen change, a clear line crossed. And with it, confirmation of something humanity had feared for centuries but never had the courage to say out loud. The perimeter of our solar system is well defined. It is a wall. Beyond that, something shifts. Music. When Voyager 2 crossed the so-called heliopause, the boundary where the sun's influence ends and true interstellar space begins, it was expected to be gradual, almost poetic. Scientists thought the solar wind would disappear into the space between stars like a slow-dissolving mist. But Voyager 2 detected the opposite. The transition wasn't slow. It came quickly. One moment it was inside the sun's protective bubble. The next, it was beyond it, in an environment where radiation increased by more than 70%, plasma density jumped, and the very structure of the magnetic field altered. It seemed like stepping through a door into a completely different room. The indications were not understated, they were abrupt, sharp, as if a membrane had been pierced. What stunned researchers most was not merely the existence of a boundary, but its precision. The sun's heliosphere, once thought to gently bleed into space, was now revealed as a distinct structure resembling a shield, one that had been preventing the commotion of the galaxy. And as Voyager 2 stepped through, it confirmed that our solar system is not simply suspended in space. It's protected by something up to now. The concept of the heliosphere has existed for decades, thought to be theoretical, a bubble of magnetic and plasma energy shaped by solar energy. But Voyager 2 proved it was more than speculative, it was crucial. Conditions inside this shield are stable, radiation is filtered, space weather is controlled, and cosmic rays are diminished. Yet the moment Voyager 2 stepped out, all of that changed. The data showed intense particle energy, chaotic magnetic flux, and hazardous amounts of galactic radiation. The solar system suddenly appeared as a fortress rather than a lonely outpost, and entering its confines meant stepping into an unregulated frontier. The soft boundaries and smooth curves in textbooks, which once existed, have been replaced with sharp spikes, hard numbers, and terrifying repercussions. Voyager 2 was no longer just drifting, it was being shot at. The sun's magnetic field was almost perfectly aligned with the field between stars, a phenomenon no one expected, one that raised concerns that the galaxy's own structure might be shaping the space all around us. It was more than just a field, it marked a threshold, and crossing it had consequences. One of the most shocking revelations from Voyager 2's data, the heliosphere is not static. It breathes, it moves, it contracts and expands based on the 11-year cycle of the sun, altering its shape and thickness as solar activity rises and falls. Voyager 1 and Voyager 2 neither crossed at the same location nor at an identical distance, and the distinctions were not random, they were shaped by the tempo of the sun. This indicates that our solar system's boundary is not a smooth sphere. It's distorted, almost comet-shaped, with pulses that ripple outward like a giant breathing organism. It stretches at times it recoils. And if the solar wind weakens, the boundary draws closer to home, allowing more galactic radiation to enter. If it grows stronger, the barrier expands, protecting us more effectively. The conclusion is disturbing. Earth's protection isn't permanent. It shifts. It can fail. And Voyager 2's sharp transition into the galactic medium demonstrated exactly how thin that veil truly is. The universe beyond is not a void. It's violent, unpredictable, and much closer than we imagined. Something strange happened in 2019. Voyager 2, dependable for more than 40 years, went silent. For a brief time, only a few minutes, each instrument went offline. No orders were sent from Earth, no updates were sent. Then, as mysteriously as it went dark, the spacecraft rebooted, recovered. The official reason was possibly aging hardware or a minor flaw in the software, but concealed in the technical reports were notes on unexplained electromagnetic spikes right before the blackout, changes in particle energy, sharp surges, and a magnetic field shift, small but not insignificant. The question that persisted was not simply what caused the problem, but where Voyager had just entered. Some researchers suggested it might be a pocket of highly energized plasma, a ripple from a distant supernova, or a shockwave from another interstellar event. But others quietly questioned whether it had entered a layer or zone we hardly knew existed, one with properties so alien their presence couldn't be predicted. And in that case, it was more than just a system glitch. It was a response. As Voyager entered the area outside the heliosphere, it began recording fluctuations in radiation levels and plasma density that were out of line with anything previously modeled. These were not merely sporadic spikes or irregularities. They had a pattern, persistent, dynamic, almost like a weather-like phenomenon. The idea that space beyond the sun's reach might contain something akin to weather was previously dismissed as poetic exaggeration. However, Voyager 2 was recording waves of high-energy particles, sudden changes in the magnetic field's direction, and surges in galactic rays that reverberated with an odd rhythm. Initially, scientists attempted to connect these perturbations to previously known solar events, coronal mass ejections, or flares that may have reverberated through the heliopause. But when those timelines didn't match, they turned their backs. The patterns it began aligning with a galactic, distant phenomenon, which may be relics of supernovae or the collective force of massive stellar winds far from our system. It was as if Voyager had entered a region alive with activity, a kind of interstellar sea with invisible currents and unseen tides. At this point, the probe was outside the sun's protective barrier. It was fully exposed, floating through a storm we never expected to find. One of the most unexpected results from Voyager 2's crossing was the near-perfect alignment of the sun's magnetic field with the galactic beyond. This discovery left theorists scrambling. For decades, models predicted turbulence at the heliopause, a clash of magnetic directions, a blending zone where solar and cosmic forces would transform into chaos. But that's not what Voyager found. The transition was smooth, as if the fields were already synchronized. The possibilities emerged, both alarming in equal measure. Either the region beyond our solar system had been shaped and bent by the sun's outflow over time, gradually evolving into alignment, or the area as a whole was already inherently aligned. That would mean the sun and its surrounding interstellar neighborhood had evolved within a magnetic harmony, possibly spanning a much larger section of the galaxy than previously believed. It also means cosmic rays might flow in more easily when fields are aligned, creating efficient channels into our solar system during quiet solar cycles. This wasn't just a magnetic surprise, it was a paradigm shift. The idea that the galaxy's structure might already account for or even plan for the sun's magnetic reach challenges every model of interstellar interaction. Suddenly, space didn't seem so chaotic. It seemed organized. As Voyager 2's data continued to flow, a whisper began to spread among mission insiders and theorists, one they weren't ready to put on record but couldn't ignore. What if the heliosphere wasn't just a boundary? What if it behaved like a checkpoint? The sharpness of the transition, the perfect field alignment, and the consistency of radiation spikes across the board for both Voyager 1 and 2 suggested not only a physical interface but a responsive one. Some proposed the boundary might be adaptive, adjusting its intensity or location in response to pressure from either side. But a more controversial idea emerged, that the boundary itself might serve as a kind of galactic tripwire, a region where entering objects are exposed, measured, recorded. This was no claim of aliens, no assertion of intelligent design, but simply the observation that the space Voyager had entered felt structured, layered, reactive. If true, this would imply that each object leaving the solar system doesn't just exit the sun's territory. It announces its presence to the galaxy beyond. Voyager may have unintentionally sparked more than just measurements. It may have sent a signal, revealing more about us than we ever intended. Voyager carries a message, a golden disk etched with humanity's greetings, sounds, music, and diagrams, a beautiful attempt at interstellar diplomacy. But within that disk are detailed instructions, how to find Earth, how to read the disk, how to understand who we are. For decades, this was celebrated as a symbol of hope. But in light of Voyager 2's discoveries, some now see it differently. If the boundary separating our system from the galaxy is not a gradual dimming, but rather a clearly defined edge if it responds, if it watches, then what does it mean that we attached a map to our home on the very probe that pierced that edge? Were we extending a hand or revealing a vulnerability? Every time Voyager sends a signal, we confirm our intelligence, our technology, and our location. If someone is listening out there, or worse, responding, then the golden record may become more than a message. It might be an invitation we can't take back. Voyager 2 wasn't supposed to survive this long. It wasn't meant to send back revelations that would shake our understanding of the cosmos. Yet here we are, decades after its launch, traversing the icy silence of space. It has pierced a boundary that was never meant to be crossed so easily. What it found wasn't the peaceful emptiness we once imagined. It found change. It found pressure. It found structure. It confirmed what many quietly feared: our solar system is not floating aimlessly in a void. It is shielded. Outside that shield, the rules start to change. Radiation intensifies. Fields align. Particles shift. Time and space distort. The boundary is firm, sharp. What lies beyond it appears less like a sea and more like a gate, a cutoff point into a realm that has no regard for our gentle sun or Earth's clear skies, a realm where apocalyptic calamities rage and fields dance to frequencies we've only just begun to comprehend. And there, the golden record sails into deep space with our coordinates, our biology, our identity carved in gold, a beautiful, reckless symbol of our optimism, a greeting or a flare sent across a boundary we now know is far more complex, far more reactive than we ever dreamed.